In this section, we'll talk about continuous random variables. So a continuous random variable is something that can take any value in an interval of numbers. I always remember this by thinking of, it could be decimals. Okay. So like if you're thinking about gas mileage, you could have like 26 miles or 26.01 miles per gallon or 26.013456 miles per gallon. If you could theoretically be any decimal, that's going to be a continuous random variable. So a probability distribution of x for a continuous random variable will be described by what we call a density curve. Basically, it's a curve. Instead of having graphs for our discrete random variables where you can only have certain values, any value is possible, so you have to have a continuous curve. Now we'll think of probabilities as events, or the probabilities of events as areas under a density curve. Now any density curve has to have a total area of 1 because you have total probabilities of 1. And you can't assign probability to each individual outcome because there's so many, infinitely many possible values. So the probability of any individual outcome is 0. So probability of x equals 8 equals 0. Instead, we'll assign probabilities to intervals of numbers. So like the probability that x is greater than or equal to 8, or x is between 3 and 8, etc. And because x equals 8, or because the probability that x equals 8, specifically just 8, is 0, it doesn't matter if we say x is greater than or equal to 8 or just x is greater than 8. Now this is only true for continuous random variables. So to show you what we mean by the probability being the area under the curve, if I want the probability that a is between x and b, here's a, here's b, and I look for all the area in between a and b, that area is the probability that x is between a and b. So for example, the temperature of a randomly selected cup of coffee at a restaurant is a continuous random variable. Temperature can be any value, any decimal, so that's why it's continuous. Let's see, suppose that we know coffee should taste the best between 153 and 167 degrees Fahrenheit. The restaurant might then wish to find the probability that x, the temperature of a randomly selected cup of coffee at the restaurant, will be between 153 and 167. So to find that probability, you just look at the curve. Now, I don't know what this curve is going to look like. Maybe it'll look like this, or maybe it'll look like this. Who knows? We don't know. But I do know if I want that probability, I would find 153, 167, and the probability is just the area in between them. Or if this was 153, 167, again, the probability is just the area in between those two values.